Welcome to the Mosquito DragNet project presentation. Mosquitoes, Anopheles species, Aedes species, and Culex species, are important for the transmission of widespread infectious diseases, including malaria, yellow fever, chikungunya, dengue, and Zika worldwide. Globally, 249 million malaria cases were estimated, and 608,000 malaria deaths were reported in 85 countries. The African region was home to 94% of malaria cases, that is, 233 million, and 95%, which is 580,000, of malaria deaths. Furthermore, over 7.6 million dengue cases have been reported to WHO in 2024, including 3.4 million confirmed cases, over 16,000 severe cases, and over 3,000 deaths. Mosquitoes also transmit several diseases and parasites that dogs and horses are very susceptible to, which include dog heartworm, West Nile virus, and Eastern equine encephalitis. It is evident from the data that diseases carried by mosquitoes must be prevented, eradicated, or controlled. The genesis of this project is that many mosquito control methods are not ecologically friendly. Some trap design are expensive and proprietary. Few traps are in existence compared to the large area of the activities of the mosquitoes, thus, surveillance is still limited and chemicals are still needed in some scenarios. So we decided that the best way is to install large numbers of traps using a community of people and make the design free for all to reproduce. The design requires AI and life science LLM so as to get the best result. Furthermore, the design is so simple and cheap, approximately $1, for anybody with craft skills to build. We are also aware that it will task the scientists involved in mosquito surveillance with the large number of specimens that will be submitted to them, so we are collaborating with them, taxonomists, on building an AI-inspired sorting and identification machine as well. However, in this presentation, we are showcasing the step-by-step construction of the community-oriented trap and all it takes to build one. We start with 2 boards. First board. Second board. Make sure it's up to 12 inches in diameter. Mark concentric circles on the board as shown. Use the dimensions shown in the diagram. Use jigsaw or any other narrow saw to cut the rings out. You should get 6 rings from the 2 boards at the end. Cut 6 straight bars, in pairs, for support, with 1.5 inches difference in their heights as shown. Each pair is for different ring set. We have used circle outline, however, we can use other shapes also. Triangle, square, rectangle, or polygons such as pentagon and hexagons. Here is a preview of the assembly after gluing the parts. wire mesh for wrapping the assembled structure. The wrapped structure with the wire mesh. Cut out rings from the wire mesh for covering the bottom. Cut holes in the wire mesh. The network of holes, the pattern, the size, and the arrangement and density are from the use of AI implementation of life science LLM on the behavior of mosquitoes seeking its victim. Preview of the 3 trapping structure with covered bottom. More preview of the trapping system, facing down. The inner trap, painted black. Also coated in black paint is the middle trap. Preview of the inner and the middle traps. Preview of the inner and the middle traps and the outer traps. Plan view of the assembled trap with the upper wire mesh in place. The material we selected is a used plastic, covered with paper tape. And marked with spots for the bait to flow out. Drilled exit holes for the bait. Put the core, that is, the bait container, in its place. Some possible areas where you can install the trap. Note that no external thermal/killing device is installed in the following presentations. It can be installed indoor, such as the living room, or outside, such as near flowers. On the window, outside. In the garden area, by hanging it on a tree. It can be placed in the open places such as parks or other leisure facilities, especially for diurnal mosquitoes such as Aedes species. Or near waterlogged areas. Whichever place you put it, the core will absorb heat and retain it for extended period of time.
Thank you from all of us at Ahmadu Bello University Mosquitoes DragNet project team.